Hello everyone, this is Mrs. Padmashri from SNS College of Engineering, Coimbatore. Today I am here to discuss about the machine learning topic, and today we are going to see probabilistic generative models. In that I am going to explain about the Bayes algorithm. So basically, in this session, we are going to explore what is the difference between the generative model and the discriminative model, and the example of discriminative model called Bayes algorithm. Let's move on to the slides. Generative versus discriminative model. What is the generative model? The generative model learned join probability, which means P of x comma y, where x is dependent on y and y is dependent on x. Whereas the discriminative model learn using the conditional probability, which means P of y or x, which means y and x, or we can say x and y, both are the independent variables, and the generative model can synthesize the new data, which means it generates a new data. But the discriminative model focuses mainly on decision kinds of data, like decision boundaries, and the generative model estimate the data distribution, whereas the discriminative model directly classifies the data. So in which we are going to see today the example, one of the example of this discriminative model, which means it uses the conditional probability and it takes decision based on the boundaries, and it directly classifies the data. Such type of algorithm is called naive-Bayes classifier algorithm. So what is this naive-Bayes algorithm? First, we'll just see the names of naive and Bayes. So Bayes, so it is basically using the theorem called Bayes theorem in the probability mathematics. We had already discussed about this Bayes theorem, right? It is a theorem which is working under the uh, probability and statistics. Okay, naive-Bayes algorithm is a supervised machine learning algorithm which works based on Bayes theorem. So it is mainly used for classification problem. So what kind of classification? It classifies the text, which includes a high dimensional data sets, high dimensional training data set. So mainly for using the text classification, we are going for naive-Bayes classifier algorithm. It's one of the most simple and very easiest algorithm which does the classification, which mainly helps in building the fast machine learning model that makes quick prediction. It is also called a probabilistic classifier. It predicts on the basis of probability of an object. So let's see what are all the applications of this naive-Bayes classifier algorithm. It's mainly used for spam filtration, sentimental analysis, and classifying the articles. So why it is called the naive-Bayes? So I'm here to tell about what is this name called naive. Why it has come? It is like it assumes that the occurrence of a certain feature is independent of the occurrence of other feature, which means, say for example, if you take a fruit called apple, like it is identified basically with the color, size, taste, which is the color red in color, shape is spherical, and recognized by the sweet of the fruit, right? So all these are the features that describes about a particular fruit called apple, right? So each feature individually contributes, which means that each feature is independent of the another feature. So naive Bayes, which easily classifies those features, the independent feature, and also it is involved, it just checks the predicted and the actual output, and what is the accuracy of those output. All those classifications are done by the naive-Bayes algorithm. So it depends on, as I already said, depends on the principles of Bayes theorem. So let's see what is a Bayes theorem. Bayes theorem is the mathematical foundation for naive Bayes. We can the formula for Bayes theorem: P of A or B equal to P of B or A into P of A by P of divided by P of B. So Bayes theorem is also called as the Bayes rule or Bayes law, mainly used to determine the probability of a hypothesis, which means which determines the prior knowledge, the hypothesis with the probability of a hypothesis with prior knowledge. It mainly depends on the conditional probability. For example, like we can say P of A or B. What is the condition, the probability of a hypothesis A on the observed event B? Okay, so it is also called as posterior probability. So when we say P of B by A, B or A, it is called a likelihood probability, which means probability of the evidence given that the probability of the hypothesis is true. So what is the next is term P of A, it is called a prior probability, probability of hypothesis before observing the evidence, and P of B is called the marginal probability, which is also called the probability of evidence. So Bayes theorem works on these things like posterior probability, likelihood probability, prior probability, and the marginal probability. So the working, let's see how this Bayes theorem is working of a Bayes classifier. So let's take the example of a data set called weather prediction, and the corresponding target variable we are taking is play. So the problem here is you need to find out if there is a rainfall or if there is a sunny climate, whether the player can go for play or not. This is the problem that we are going to solve today, and the rest, the steps need to solve these problem will be discussed in the next my next video. So thank you for watching me.